Hello friends, welcome back to our channel. So today we'll see one more concept in compiler design, that is syntax directed definition. Syntax directed definition. And this is also called as syntax directed translation. Okay, so whatever it may be, let's see what is exactly the syntax directed definition, right? So in our previous session we have discussed about the different types of parsers, right? So that is the second phase output where we will be getting the parsers. So we have seen a lot of parsers: LR parser, SLR parser, CLR parser, etc, etc. And also we have seen some ACT tool which will generate these parser, right? Now, so the output of that parser is a parse tree. Okay, so parse tree. For all the types of parsers, the output will be the parse tree. So either it may be a bottom-up parser or the top-down parser. And now we have to improvise this parse tree. We are supposed to improvise the parse tree, right? How to improvise the parse tree? And this is called as SDT or SDD, means syntax directed translation or syntax directed definition. Okay, now how it will be improvised, the parse tree, how it will be improvised. So for every symbol, so here we are supposed to discuss about two types of symbols. We are calling them as, see, terminals and similarly non-terminals. Terminals and non-terminals. And we have seen these non-terminals can be expanded and terminals can't be expanded, right? So terminals can be expanded. And also we have seen these terminals will be the leaf nodes. Leaf nodes. So that's why these terminals can't be expanded. That will be the last one. And if it is a non-terminals, that can be expanded until it reaches to the leaf nodes. So particularly for these non-terminals, okay, for these non-terminals, there will be an attributes. There will be an attributes, right? Like properties. We can say them as a properties. So for every non-terminal, that there can be 0 or more number of attributes. For every non-terminal, there can be 0 or more number of attributes. Okay, so one such attribute is a value. So value. Okay, every non-terminal will be having some value. Okay, and leaf nodes. For leaf nodes, there will be no attributes directly. We can have the lexical value, direct value, right? For example, see, there is a productions like E plus T, E tends to T tends to T into F, T tends to F, and F tends to ID. So already we have seen these kind of productions while generating the parsers, right? So here you can see E, T, F, all these are the non-terminals. And whereas ID is a terminal. So how we can write it? So for example, if you want to give ID plus ID into ID. So if you want to parse this particular input string, what we are doing simply, so we are first we are taking this production, we are starting from the initial production. So E tends to E plus T. So where this E can be, okay, E can be considered as a T, right? E with a T, and this T can be considered as a T into F. T into F, because so this is similar with this one. Okay, ID plus ID into F, and this T can be expanded with the F, and this T can be expanded with F, and this T is already F. So plus and star. Now it will be ID. It will be ID. It will be ID. Star and plus. So this input string can be passed by using these productions, right? So that means every non-terminal will be having an attribute. So that should be evaluated. So for every production, there will be some sort of rules. For every production, there will be some semantic rules will be applied. And that semantic rules and this kind of productions combinedly call it them as a syntax directed definition. For example, see what we are doing here. So E is equal to T. What we are doing here, T is equal to T star F. And again, what we are doing here, T is equal to F. What we are doing here, T is equal to F. That means for every production there will be some formula. So here I'll write it. So this can be written as E is equal to E plus T. And this can be written as E is equal to T. And this can be written as T is equal to T star F. And this can be written as T is equal to F. And this can be written as F is equal to I. Right? So all these are called semantic rules. And these are called productions. We know that. Productions, and we are usually calling it as context-free grammar. We are calling it as a context-free grammar. So what is this SDT? SDT or SDD? Okay, syntax directed transition or definition is equal to context-free grammar, that means these kind of productions, plus some sort of semantic rules. So semantic rules is called as a SDT, syntax directed definition or syntax directed transition. Syntax directed transition. Now, see, hope you understood this one, right? So these are the productions. We call these as a productions and these as a semantic rules. Okay, so in order to evaluate this kind of expression, what we have to do? So with the help of these productions and with the help of the corresponding semantic rules, we have to calculate the expression. We have to calculate the expression. So this is what happens here. Now, here for applying these semantic rules on the productions, what we have to do? So we have to find out the attributes. There are different categories of attributes. Okay, so for every, see, one thing I will tell you, the symbols will be having attributes. Productions will be having semantic rules. Remember this one, definitely you will be understanding everything. For symbols, there will be an attributes, the properties. Okay, for example, capital T. So capital T is having some attribute called value. So if any value should be taken, that will be T dot value. So here you can write it as E dot val, E dot val, T dot val. So these are all the semantic rules. Okay, so rules are associated to the productions and attributes are associated to the symbols. That too particularly are non-terminal symbols. Non-terminal symbols. Right? Now, see, these kind of attributes are two categories. Okay, so two category of attributes. One is synthesized attributes, inherited attributes. Synthesized attributes, inherited attributes. Synthesized, inherited. Okay, how the, so both comes with the non-terminals only. Okay, both comes with the non-terminals only. But coming to the synthesized attributes, those are the non-terminals on the left hand side. Okay, so non-terminals on left hand side. And inherited attributes, these are the non-terminals on right hand side. Non-terminals on right hand side of production for any production. So where we are having these non-terminals means in productions itself, right? So in productions, so on LHS, whatever the non-terminals we are having on LHS, those comes with the synthesized attributes. And the non-terminals which are available on the right hand side of the production are called as a inherited attributes. See, we'll take an example for synthesized attributes and the inherited attributes, and then we'll move on with the different categories of SDDs. Syntax directed definitions. Okay, yes. Let us consider. See, synthesized attributes. Synthesized attributes. So as I said, the non-terminals on LHS of production. Okay. So example, I'll write an example. For example, some A tends to B, C. A tends to B, C. Now, how will we get the value of A? So, coming to the semantic rule for this one is A dot value is equal to B dot value and C dot value. Okay, A dot value is equal to B dot value into C dot value. So how we can get this A dot value? So that A dot value will be getting from either B dot value or C dot value. So here B dot value is again expanded because B is a non-terminal, C is also a non-terminal. So A dot value, so the value of A will depends on children like B and C. Okay, so this is one more point. Value of A will depends on children. So here only remember the non-terminals on left hand side. So don't consider B and C. Don't consider B and C. Okay, it will also follows the bottom-up parsing. Okay. Next, the second category is inherited. The second category is inherited. So here, just now we have seen these are the non-terminals on right hand side. So non-terminals on RHS of production. So you need not worry about the left hand side. Okay, you need not worry about the left hand side. So inherited attributes are the non-terminals on the right hand side of the production. So here example S tends to A, B and C. S tends to A, B, C. Now which one will be the inherited attribute? So A, B, C will be the inherited attributes. Okay, so here the inherited attributes are A, B or C. For example, consider some B. Okay, consider some B. Now a value of B depends on parent. So what is the parent here? Yes, or siblings. Who are the siblings here? For B, A and C. So if you want to calculate the value of B, okay, the attribute value of B, then it depends upon parent or the siblings A and C. So such kind of attributes we call it as an inherited attributes. Such attributes we call it as an inherited attributes. And usually it will be following the depth first. Depth first passing. Okay, so these are the two categories of attributes: synthesized attributes and inherited attributes. Right? Now, we'll see the different categories of SDDs, syntax directed transitions. So here SDD is also categorized with two different categories: S attributed SDDs, L attributed SDDs. So I'll write here SDD, S attributed, L attributed. S attributed SDD, L attributed SDD. Okay, so the name itself indicates here S attributed SDD will be using this synthesized attributes, and L attributed SDDs will be using the inherited attributes with some constraints, some sort of constraints. Now we'll see what is the S attributes and L attributed SDDs, the categories of SDDs. See, simple example, S attributed SDD. So first it uses synthesized attributes, and it will be using the bottom-up parsing. Just now we have seen bottom-up parsing. And then see example, you can say A tends to B and C. So the A value will be depends on B and C. Now next one, L attributed SDD. What is this L attributed SDD? See, this L attributed SDD uses inherited attributes. It uses the second category, inherited attributes. So what is meant by inherited attributes? So here with some constraint, very important, with some constraint. So we have to focus on this constraint. What is a constraint here? Okay, so example, let us take some A tends to B, C, D. Now, see, value of C depends on if it is an inherited attribute. What we have said, it depends upon the parent and siblings. Parent or siblings. So here the constraint is only left sibling. Here the constraint is only left sibling. Okay, so here C depends on A, parent, and what's the left sibling of C? B. It's a left sibling. Only this one. So the value of C doesn't depends upon D because it's a right sibling. So this is the only constraint. This is the constraint. Okay, this is a constraint of L attributed SDD. Right? So hope you understood this one. Right. Now we'll see one parse tree. Okay, we'll see one parse tree, and let me explain the improvised parse tree. Okay, what is a parse tree? And I'll write here the productions. E tends to E plus T, and E tends to T. T tends to T into F. F tends to T tends to F, and F tends to ID. So these are the productions. These are the productions. Then what about the rules? So coming to this one, E dot val is equal to E dot val plus T dot val. Similarly, E dot val is equal to T dot val. Next, T dot val is equal to T dot val into F dot val. And T dot val is equal to F dot val. And F dot val is equal to ID. See. So these are all semantic rules. Semantic rules. And these are all productions. Okay, the semantic rules and the productions. Now the input is ID plus ID into ID. So how it can be represented here? First start with the starting one, E, which can be expanded with the three terms, that is E plus T. Right? Now this T can be, so this E can be expanded to T, and this can be expanded to T into F, and this can be expanded to F, and this can be expanded to F, and this can be expanded to ID, and this can be expanded to ID, and this can be expanded to ID. So the leaf nodes are all terminals. Leaf nodes are all terminals. Now what this can be improvised in this way. See, E plus T, and the same thing, T star F ID. So this can be written as, see, what is this one? From bottom up. Go with the bottom up. So this is a ID. So ID dot lex val. That means a direct value. It's in a value, right? ID dot lex val. ID dot lex val. Direct value. Here F. So in this, here what happens? F dot val is equal to ID dot lex. F dot val is equal to ID dot lex. What happens here? Here also F dot val is equal to ID dot lex. What happens here? Here it is T dot val is equal to F dot val, and here also T dot val is equal to F dot val, and here what happens? E dot val is equal to T dot val. Okay, and here T dot val is equal to T dot val into F dot val. Okay, and this E dot val is equal to E dot val plus T dot val. So like this, it can be improvised with the help of the attributes and semantic rules. So here there is a direct value, and here F becomes, we are getting the value of F with the help of a children. And here we are getting the value of t from its children. And we are getting the value of t from its children, t star f. So like that, this SDT will be formed. So the productions plus the semantic rules. The productions plus the semantic rules is called the SDD. So the attributes we have seen, the attributes as two categories, synthesized and inherited. Similarly, SDT, syntax directed, L attributed, S attributed. Right? So this is all about our syntax directed definition. So the value, so whenever you are drawing the parse tree, that can be improvised with the help of the semantic rules given for each and every production. So once again I'm saying, every symbol, every non-terminal will be having 0 or more attributes, and every production is associated with some semantic rule. And these are called as a semantic rules, and dot val is one of the property or attribute of the particular non-terminal. Right? So let's stop here. We have seen these things, different types of attributes and different types of SDTs. Right? So let's stop here. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.